The next type of greatest common factor we're going to look to do is a GCF, or a greatest common factor. That's a binomial. This technique is going to lead us to be able to do one type of factoring, which is known as factoring by grouping. And factoring by grouping involves the greatest common factor at two levels. But these first three questions that you're going to see are going to be the precursor for this type of factoring. So let's go ahead and look at these first three questions, and then we're going to tackle factoring by grouping. Factoring by group is going to be an essential type of factoring, especially for factoring trinomials that have an A coefficient greater than 1. So let's go forward. This is going to be question 74 from section 6.1. So we have R times t minus 3 minus s times t minus 3. So when we look at this as a term and this as a term, we see they don't really have any particular monomial in common. However, if you look at r as being a factor and then t minus 3 being a factor, and then s as a factor and t minus 3 being a factor, the one thing we recognize, using a wide parenthesis, is that both this and this have the quantity of t minus 3 as a common factor. If we factor t minus 3 from this, what we see is once t minus 3 is factored, we now can remove this and we are left with a quantity of r minus s. Now this is a lot of empty space, but I leave this here to illustrate what is factored out and what remains behind. So below we can rewrite this as t minus 3 times r minus s. Now I'd just like to comment on something on a few of the comments that were left behind by some of the students. Some students had mentioned that they would have liked to have seen me leave the original problem intact in order to see the work. If you want that, that's fine. I can't stop you from writing what you're writing. In order just for me to save time and to save paper, I don't do that. However, if you want to write the original problem and then write it again to show the work here, there's nothing stopping you from doing that. So if you think that would help to do that, please go ahead and do so. Remember, you can stop this video to help you anytime you want. So going back to this problem, by factoring out a common binomial, we end up with two binomial factors here. Let's go ahead to 76. We have a to the fifth times a not a to the fifth, a plus fifth, a plus 5 times a minus 2 plus, or a plus 5 times a plus 1. So what we're going to do in this problem here is we are going to go ahead, make a big parenthesis, and we're going to see which binomial is in common. And mainly that's going to be a plus 5. So we look at this, we look at this, we see that a plus 5 is the binomial that's in common. And if we remove that, we are then left with a minus 2 plus a plus 1. Now, could we somehow consolidate these? Yes, that could be done. And in doing so, we would get the quantity of a plus 5 times a minus 2 plus a plus 1. So another way you could write this, if you wanted to take it further, is the quantity of a plus 5 times, let's see, a plus a, 2a. Negative 2 plus 1 is minus 1. And this could be further consolidated if you wanted to multiply this together, but that's not what we're really looking to do. You won't have to do work typically like this often. The focus of the lesson really is to identify what binomial that's in common and how to factor it out. One more like this. We're going to go ahead and take a look at question 78. This is going to be 5x squared times x minus 6 plus 2 times 6 minus x. So, a little bit of a different technique here, because if you were to look at these two binomial factors, you would see that these are not quite exact. So there's a little trick that we can do with this here. And it's something that we could, well, let's take a look. I can go ahead, and I'm just going to kind of write this like so. I can take 6 minus x. And what I'm going to do is I'm going to go ahead and I'm going to factor -1 out of it. Now, I don't have to, but you'll see how it helps in just a moment. By factoring -1 out, I need to switch the signs of what's on the inside. By doing so, I get -1 times -6 plus x. Well, I can write -6 plus x as x minus 6. But I have to have the -1 here. So we're going to come back with this here. -2 times -1 times x minus 6. And I'm going to take this 2 times -1. I'm going to make this -2. So by taking positive 2 and -1, multiplying them together, I get -2, and that's going to be -2 times x minus 6. And this is going to be 5x squared times x minus 6. Now, again, this is going to be something that will not come up terribly often, but may come up once in a rare while. So let me rewrite this step toward this part here. 5x squared times x minus 6. So not changing anything from here, just rewriting it to continue the work. The common binomial I can factor out is x minus 6. When I do that, that's going to leave me with 5x squared minus 2. So I can consolidate this by writing it as x minus 6 times 5x minus 2. So I have now successfully factored out this original trinomial that we had in this problem and factored into two binomial pairs. So it is this type of factoring that we're now going to use by combining it with the greatest common factor to engage in a type of factoring called factoring by grouping.